Okay, today is I'm the day of team. I'm Winnie, so I represent our team to make the final presentation. Uh, our team is to do the productivity prediction of the government employees. Okay, let's have a look for the outline. For my outline is firstly I will give some the introduction of our data set and the data overview, and then we'll have the data cleaning and the data exploration, and also I will show the dashboard. I use the tabular, and then I will do the prediction of the productivity. So, for the introduction part, the government industry is one of the key samples of the industry globalization of this modern area. It is a highly labor-intensive industry with lots of the manually processed, satisfying the huge global demand for the government products is mostly depend on the production and delivery the performance of the employee in the government manufacturing companies. So it is highly desirable among the decision makers in the government industry to check, analyze, and predict the productivity performance of the working teams in their factory. This dataset can be used for the regression purpose by predicting the productivity range for the classification purpose by transforming the productivity range 0 to 1 into the different classes. This data, like the donate, is on the August and 2020. For the data overview, the data set characteristic is the variable and the time series. And then the attribute characteristic is object, integer, and the float. The number of the instance is the 1197, and the number of attribute is 15. We have the missing value. I should highlight the two the attribute. One is SMV, is the standard minutes value. It is the allocate time for a task. And it is work in process. The number of the unfinished item for the products. To do the data cleaning. For future explore the data, we changed some time of the data. For example, the day column, we changed it from the object to the daytime. And for the team column, as both two departments has 12 teams, we changed the team name from the integer to object. And then we have one missing value column is WIP. As the WIP is integer, so we're using the 0 to fill in this column. We use the pandas to do the data clean. For the data exploration, the data is from the 2015, the 1st of the January, and to the March of 11. The Fridays are off days. Each month as a separate quarter per week. 12 separate teams from the 1 to 12. And the two separate departments is swimming department and the finish department. Uh, when we explore the data, so we have the questions, what will be effect on the result of the actual productivity? We assume the date and the date at the, maybe the Monday to the Sunday, yeah, is any like should is the main reason to embed the data. Also the each team and also the number of worker in each team incentive paid to the swimming department or the finish department, and also the idle time and the idle number of the workers. So let's move to our dashboard. For this dashboard, is to the motivation of the productivity. So let's have a look for the key KPI. The target productivity is the 72.96%, and the actual productivity is the 73.51%, and the total incentive cost is the 45,738. A huge number of the workers in each team, even though they were in the same department, like the swimming department, the team 6 and the team 12. The number of workers were roughly is the 35 in the team 6, and the team 12, the number of the worker is okay, sorry. The team 6 and the team 12 have the less number of the worker roughly is of 35, and the team and the other team is roughly is 55 workers. However, the team 6 and the team 12 have the less worker, but they can work well. They have the less like the SMV and the less over the total overtime. But we find a question. As the team 6 and the team 12 is not the team 6 and the team 7 is less less number of the worker, but they get the less the incentive. We can assume that the swimming team can work made more difficult than the Finnish department. So the swimming department have the more work like the WIP during this quarter, and the Finnish department is only have the WIP in the final part. After the analyze, so we have some recommendation for both the Finnish department and the swimming department. Oh, sorry. Swimming team will get the incentive for each month, but the Finnish department will get the incentive at the end of the quarter. Just the Finnish departments assigned the worker is roughly the 9 to the 12, as they didn't impact by the incentive. So the company can reduce the incentive for the Finnish department. And for the swimming department, we need to assign to the worker to the more groups. As the previous exploration, we found that it's more workers in that team may increase the overtime. And also keep each group the size is to the 35 to the 45 workers. There is the no dividend variable that has a strong correlationship with the target variable. Most correlationship between the attributes are weak and insignificant. There are only a few moderate and a strong positivity correlationship. The SMV and the number of worker have the strong positive correlationship. It's a 0.91. This makes sense because they could expect the longer the task, the more worker are allowed to it. The overtime and the number of worker has a moderate positive correlationship, as well as the overtime and the SMV. And also, I want to highlight the idle time and the idle man also have a moderate positive correlationship is the 0.56. Is the more likely because they are most 0 second. I will idle time and the idle man from the data to build the AI model as because this is not the main reason to make the prediction. Our aim is to predict the productivity performance of the working teams in their factory. We use the two AI model. The first one is a linear regression model. The second one is the decision tree classifier model. We split the data sets. The test size is the 0.2, and to avoid the overfitting and enhance the training test. This is the activity and the predicted productivity. This one is the linear regression model, and this one is the decision tree classifier model. It looks quite similar. For the model evaluation, we use the accuracy and the validation and the precision and the recall to to evaluate these two models. After our to do the calculation, we find that the decision tree classifier model is better. In the conclusion, after I explored this data set, I found that the data is not sufficient because it's only is not enough. I think collecting more data can get the accurate forecast. And also, I found that the data is quite old. As I mentioned at the beginning, the data donated in 2020, but the data is a 2015. It's like it generate is a 2015, but donate is 5 years later. And also, it's no clear currency in the incentive. Okay, this is our team. Thank you.